welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports us on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or experimenting with something that you hear about on the show. You can visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macey, and today I'm interviewing David Barroso and Mircea Ulinic about NAPALM, Network Automation and Programmability Abstraction Layer with Multivendor Support, the library for managing programmable network devices. So, David, could you please start by introducing yourself?
Sure. My name is David Barroso. I'm a network systems engineer at Fastly, where I spend my time automating networks and also trying to build networks where the application can actually decide how to route the packets themselves. And before that, I was at Spotify, which is actually where this project started.
Hi, I'm Mircea. I'm also network system engineer at Cloudflare, where I have the chance to automate one of the biggest global networks. We have a more traditional approach to networking, like 99% of the networks in this world. And beside this, I'm a NAPALM user, contributor, and maintainer.
And David, can you start by recounting how you first got introduced to Python?
So traditionally, I'm a network engineer, although nowadays I spend most of my time coding, if not all my time. But I think it was back in 2012, I was just a regular network engineer, and I was trying to get a hold of the inventory of my network, which was living inside just a wiki page, which meant that I couldn't actually query the information. Like trying to find a device by platform or operating system or something was just a nightmare. So I was looking into trying to move all that data to some sort of database that I could actually query. And I just found Django, which seemed like a good fit for this. And that's pretty much how I started with Python.
And Mircea, how about yourself?
Yeah, my history is a bit different. I was previously a software developer. I was mostly oriented to backend of websites. I began looking at Python because I had to work with Sherry Python. That was back in 2007. I was with a group of friends and we were looking at Python. We said it's awesome, it looks very interesting, very readable and so. And 1 year later, I have ordered from Amazon a book called Learning Python, written by Mark Lutz, a very well-known author. It was only the second edition. I still remember it had a label on it saying that it covers Python 2.3. Yeah, and we are speaking now about Python 3.6 and so. Afterwards, there were a couple of years when I didn't use Python at all for like 5 or 6 years, and then I started using it again.
And so let's start by explaining what NAPALM is and the problem that you were solving when you first started working on it. So, David, I believe that you were the original author, is that correct? Or the original co-author, at least?
Yeah, that's correct. So if you take a look to most networks out there, like they're usually comprised of multiple types of devices, like firewalls, load balancers, routers, switches. They also run like many different operating systems, depending on the vendor, depending on the platform. They may even have different versions of that operating system, and each one has a complete different way of interacting with those devices. Like one may have only a CLI, another one may have a complete different CLI, then some other may have like a proprietary API, or maybe using netconf or whatever. Like there are just many ways you can manipulate these devices. So as you can imagine, if you're trying to do something as simple as just trying to figure out which IP addresses you have configured on your network, that becomes like a super hard and massive task. You have to start by figuring out to which device you are trying to connect to. Is it a Juniper device? Is it a Cisco device? Is it an Aristo device? Which version of the operating system are running? Which API they have available? So you have to start figuring out all this stuff. And it turns out that your code becomes this massive blob just just trying to figure out that part, not even trying to get the information, just trying to figure out how to get that information. So as I was trying to automate the network at Spotify, it quickly became apparent that this wasn't going to scale. So I started working on first building this abstraction layer with NAPALM. So when we were actually trying to solve a problem, we could actually focus on the problem, not on the how to do that on a particular device.
When you first started it, did you immediately decide to use Python, or did you play around with other languages for implementing it at first?
So I decided to use Python for two reasons. The first one is because it's what I knew. As I mentioned, I was a traditional network engineer, so I wasn't really a developer. I mean, I could do back then like some Perl, Bash, maybe some simple Java, but I wasn't really a developer. But I was a bit more proficient with Python, so it seemed like just the way to go. And the second reason is that some vendors had by then some libraries written in Python, so you could interact with those devices. Like Juniper had a library written by them. Arista had another one. There was also Paramico and NetMico that allowed you to interact with certain devices. So it felt like a natural fit. Just like, let's try to rely on those libraries and just have NAPALM build this abstraction on top of them instead of having to reinvent everything from scratch.
And I imagine that there's also networking devices in your infrastructure that don't have any sort of programmability aspect to them. So does that pose a challenge when you're sort of architecting the overall network and trying to integrate the sort of Juniper and Arista switches and things like that with the more traditional, just hardware-based networking systems?
Yeah, so there is a lot of equipment out there, especially Cisco iOS. It's notorious for that. Where the only thing you have is SSH and just plain text, which means that you end up with a lot of regular expressions everywhere. But the problem is not that you have to deal with regular expressions. The problem is that they may have like a minor release where they are supposedly just patching some minor bug, and it turns out that some output may change as well. And all of a sudden, all your regular expression just like broke. So yeah, the NAPALM has a lot of code just trying to manage those differences, trying to figure out, oh, is this like 16.5.1 or is it 16.5.2, and try to pick the right regular expression is just a massive endeavor doing that.
Yeah, someone made like a poll, and speaking about numbers, it turns out that only 15 up to 20 of the network devices in this world would actually have an API. Not only because vendors not support it, but historically some didn't have at all. They have only in the new versions, and there's a problem in the network world that you can't upgrade your device sometimes to the new version that has the API, or is not stable enough to make the business decision to upgrade to a new version that has the API, and so on. And basically what you have to do, this doesn't stop us. You basically start a process that connects via SSH, and you issue commands like you would do when you log yourself on the terminal and type a command, and you read that output and parse it and present it to the user in a structured format.
And one of the challenges of working with the networking layer is that basically everything on top of it relies on the fact that the network is operating properly and isn't dropping packets, or is just generally available. So I imagine that there's a bit of risk involved with trying to manipulate it programmatically in the event that you have some sort of bug in your scripting. So what are some of the ways that you try to mitigate that problem when you're working with NAPALM?
So NAPALM has a couple of mechanisms to minimize problems like the one that you were describing. The first one is that when you can create what we call a candidate configuration, then you can ask NAPALM to give you a diff between the actual configuration on the running device and your candidate configuration. So that you can actually introduce that as part of your change control workflow. So a fellow engineer could just review that change and see like, okay, yeah, this makes sense. This is not going to break anything. That's just like doing a pull request if you are a developer, right? So another mechanism is that if you detect that you broke something and you still have access to the device, we implement like a quick rollback. So you can just like tell NAPALM just like rollback, and you will go to the previous known state. So that's a nice way of just trying to fix a problem. And then we are now integrating as well with a feature that some vendors have, which is some of them call it like commit confirm, but it's basically a sort of automatic rollback. So when you do a change on the network, the device will expect you to confirm the change within a period of time. So if that period of time just expires, the device will roll back itself. It will assume that you lost connectivity to it, that something is broken, so it has to roll back. So those are the mechanisms that we have within NAPALM to try to minimize or solve problems as easy as possible, as fast as possible.
And for the built-in rollback capability, is that just caching the diff from before you apply the configuration change so that it knows how to revert it back to the previous state?
So that depends on the platforms. Like some platforms, for example, they support that feature themselves. Every time that you do a change, actually saves a checkpoint. So if that is supported natively, we will just like tell the device like, okay, go to the previous state. But if that's not supported, we will just save a local copy on the device, and then it's just a matter of reloading that configuration that we saved before actually committing the new one.
And for testing the NAPALM library, I imagine that because of the reliance on the hardware platforms and the operating systems that they're running, that it introduces a lot of complexity in terms of being able to accurately test everything at the unit level. So there must be a lot of integration testing involved as well. So I'm wondering what your overall test architecture looks like to be able to ensure that changes that you make don't introduce regressions.
Yeah, so we do two different things here. If you're doing a change on code modifies configuration on the device, that's a bit more complex because that you want to do like proper integration test against a real device. You probably don't want to mock that because it's kind of like too critical. So when we do changes to code that manipulates configuration on the devices, we use Vagrant to spin up VMs, and then we have a whole suite of configurations that we know how they look like. So we know what diff we are supposed to get before committing the change and after committing the change. So, but it's actually manual testing because we have everything on Travis right now, and Travis doesn't really work that well when you want to test many VMs with Vagrant and stuff like that. So yeah, that's the configuration management part of the project. When we are dealing with retrieving data, that's actually easier to test because then you can just mock the device. Like I know if I type this command or if I do this API call that I'm going to get this response, this text or this JSON blob or XML, whatever. So in that case, we just have like a battery of test cases like, okay, this is iOS 13, this is iOS 12.2, this is when you have this particular case where you don't have any BGP neighbors. So we just keep building cases and making sure that all the parsing, regular expressions, everything just works.
And so one of the things that I was thinking about too as I was preparing for the show is wondering how working with NAPALM relates to working with purely software-defined networking, because I know that with the NAPALM library, you're interfacing with the physical switches that have their software layer exposed via the APIs, but in systems such as OpenStack, where you have entirely virtual network infrastructure as far as the interconnect between the virtual machines, is that something that NAPALM would be able to manage as well?
So, I mean, what NAPALM does is mostly interact with the configuration of the network, right? So, I mean, if you have like your OpenStack infrastructure and you need to provision like, I don't know, like VXLAN or a VLAN or a route or something, you could actually use NAPALM to interact with the hardware to say like, okay, you have to configure this VLAN because I provisioned this new service. And I actually think that I heard some people talking about using NAPALM within the OpenStack context, but I'm not entirely certain about that.
And so, as you mentioned earlier, NAPALM sort of abstracts the different underlying platform-dependent libraries. So I'm wondering how you architected it in order to be able to easily integrate new classes of network devices and new dependent libraries while still maintaining a consistent API across the different devices.
The approach is quite simple and probably wouldn't be Pythonic. And the idea is that we have a base class that we call just like, I think it's called right now a network driver or something like that. And that base class just defines the API. It has a set of methods. It has documentation saying like, this is how the method is supposed to behave, this is what's supposed to happen, and this is the data that's supposed to return. So that sort of acts as an interface, but Python doesn't have interfaces. So what we do is we just implement, like for each particular device out there, we just implement a class that inherits from that base class. And then on the testing framework, we start comparing signatures. Like for example, this method that you implemented here, it's supposed to match the signature or your parent class, and the output is supposed to match what the parent class would be outputting as well. So we try to enforce somehow this interface on the testing framework instead of on the Python layer, because Python doesn't really have any sort of interface feature. We decided to go this path instead of using like decorators or meta classes or abstract classes or something like that, because we figured that the user base of this library wouldn't be like very proficient on Python. So we wanted to do it as simple as possible, so we could actually have network engineers that might have a lower level of Python proficiency just implementing new things and being able to contribute as well.
And when you're designing the overall API and trying to figure out which methods you're going to expose as the common denominator across all the different types of devices, how did you go about determining what those methods and type signatures were going to look like in order to be able to have the broadest set of compatibility across the types of devices that you're targeting?
So there are two parts in here as well. Like one is the configuration management part, and that one we tried to emulate what the netconf protocol specifies. So the netconf protocol, it's a well-known standard in the network community, and it has like a set of primitives, like like a candidate configuration, like a running configuration. It has certain actions that you can do. You can load the candidate configuration. You can start doing a transaction and committing the change. So for the configuration management bit, we try to emulate that part, which means that it's been quite stable since the very beginning. Like it was designed at the beginning, it was implemented, and we haven't changed that much since then. And then the second part is what we call getters. Getters are just methods that connect to the device and retrieve consistently information from the devices. So you could say like, okay, give me the BGP neighbors, and you would get the same data regardless of the vendor. So it just like parses the data and just structures it in a known format. And for that, that's pretty much community driven. Like we have a set of methods that we were using, and then as people start using the library, they might open an issue on GitHub saying like, oh yeah, I see that you're getting the BGP neighbor, but I would like to have the OSPF neighbors as well. Then we start just discussing how the data would look like, so it's as generic as possible. Yeah, and start implementing the methods as are actually needed. Like we don't really implement all the methods to all the platform. Like we just actually implement the methods where actually someone needs it.
And the underlying libraries, I'm assuming, expose their data in different formats. So I'm assuming that you have to do some measure of data manipulation in order to be able to present it in a consistent manner across all the different devices that somebody might be querying.
Yeah, that's correct. That's actually the main the main bulk of the code in NAPALM, just trying to get the text that a device might give you via the CLI and parsing it and returning a dictionary, or just converting a dictionary into a different dictionary, or this XML object that you got to whatever the method is supposed to return. So yeah, there is a lot of data manipulation.
Yeah, it actually depends very much on the driver, on the platform capabilities, and what kind of API you are able to use, or if you have an API. For example, if you are trying to automate a Juniper device, they have an API via a protocol standardized called netconf, which is on top of SSH that provides XML documents. Then you can extract your data from there. But you may not have an API, and as I said previously, you need to spawn a SSH process that connects to the device and emulates your command line, and you extract simply text then which you have to parse. So it depends very much on the platform you are trying to automate, and the underneath library in general is used only as transport.
And one thing that I was just thinking about is particularly in larger networks, such as the types that I'm sure you're working with, Mircea, and David, I'm assuming you do as well, is in terms of discovery of the devices that you're going to be working with. So do you just keep a database of all the different locations for the devices, or do you have some measure of discovery using network protocols such as ARP or whatever to figure out the types of devices that you're working with and where they're located within your network?
Yeah, we are actually having a database. In our case, it's pretty simple. Even the network is quite huge now. But we are growing, and we add a new POP with a piece of about one POP per week. And we have the time to. We started from scratch, and from the beginning has been designed with automation in mind. And at new POP, we only need to update this database to make sure that everyone understands POP. I say point of presence. That means a new collocation in a data center where we have network devices. But you can also use SNMP to detect what kind of device you have. You only need to say to provide the IP address from where to go and collect the details, and you can, for example, update automatically your database, or simply to tell you back on the CLI that I have discovered these devices that you told me they are these IP addresses, and they are, I don't know, Juniper, Arista, and so on.
Yeah, we have a somehow similar approach. We actually we have a database where we have all the information. We treat the database as the source of truth. So the device has to exist in the database even before it can be deployed on the network, because operators don't have any mean to actually connect to them and configure them. It has to be done by automation. So it's kind of like a documentation first approach in our case.
And so when you're storing the information in the database and then the device actually does get connected to the network, do you have sort of events that will trigger a run of a NAPALM set of commands to automatically provision the desired state for that device once it comes online?
So there are two parts here. When you provision a new device, we use what we call ZTP, zero-touch provisioning. That's just a way of building the initial configuration dynamically, similar to Pixie boot, but for the network. And then once that will give you just like credentials and management IP and all that stuff. So then it's just a matter of the operator actually doing an Ansible run, which uses NAPALM to build all the configuration, all the solder packages that have to be deployed on the device, and deploys everything.
And so that brings us to talking about integrating NAPALM with configuration management tooling, such as you mentioned, Ansible and SaltStack. And I'm curious as to the amount of support in other tools such as Chef and Puppet.
So Ansible, we developed the models ourselves, because Ansible, they have their own networking models, although they have a complete different approach where they have specific models for each specific platform. So with Ansible, if you want to do something with the native models and you want to do something on iOS, for example, on Cisco iOS, you have to use the iOS model that does that. If you want to do this something similar for Arista, you have to take the specific Arista model that does that. So they have their own thing, but we actually support the Ansible model. You have to install as a third-party model, but we actually support them. Salt has native models which were actually developed by Mircea, so he can probably elaborate on that. I know that Stackstorm has as well integrated modules for NAPALM, but I honestly don't know about Puppet and Chef.
No, me neither. I didn't hear anything, although it's definitely possible, and I expect it shouldn't be extremely hard. But I heard something else about a different tool called Trigger.
All right, yeah.
Yeah. About Salt, as David said, in Ansible also there are a couple of other modules provided by network vendors or third parties. But NAPALM is a very special case because it's independent, it's community driven, and you can do anything you want. It's already embedded in the core. So basically, when you install Salt, you have all the network automation capabilities embedded, and it's even more event-driven network automation and orchestration. Now the list of features is quite big now. Next release, which will happen this month in Nitrogen, there will be even more features provided. And they are not related strictly only to configuration management, also the getters part that David presented already, when you are able to retrieve data. But Salt is from a different perspective. If we zoom out a bit and look from 4,000 foot, you'll see that is much more than configuration management. It's triggered configuration management, which can be triggered when your interfaces can go down, where your BGP neighbors can start leaking routes, and so on, which can be detected either using those getters, either from other events in the network. In the network world is a very special case because it's not only about configuration management. It's often misunderstood that configuration management it's everything. It is vital and extremely important, of course, to have your network consistent. But there's a lot of things happening around that you definitely want to monitor and start acting automatically. And I would introduce here a new kit of the NAPALM suite. Is called NAPALM Logs. It's still in beta release, but we are working on it now. It collects all these events from different network devices and presents them in a vendor agnostic form, more specifically structured as per some public standards like OpenConfig or IETF. And using those events, you can ingest them in a tool like Salt or Stackstorm and so on, and you can trigger configuration changes.
Now that Mircea actually mentioned OpenConfig, I would like to talk about OpenConfig for a second. It's actually funny because I was presenting NAPALM, I think it was 2015 at Nanox 64. As I was presenting NAPALM there, the day after, Google actually presented some other effort that they were doing in parallel that was actually similar to NAPALM, which is called OpenConfig. OpenConfig uses Yang, which is a data modeling language, to define a common set of models that are supposed to be vendor agnostic and are supposed to be useful to both retrieve information from the network and to configure the network agnostically without vendor-specific stuff in there. The only problem with OpenConfig is that the OpenConfig group is way faster than vendors are, so it turns out that 2 years later, there isn't that much OpenConfig support from the vendor side yet. Like, there are very few models supported by very few platforms. So we started actually working as part of NAPALM recently on trying to start supporting OpenConfig models within the NAPALM context. So you can use NAPALM to retrieve information from the devices, like native information, for example, and map it into an OpenConfig object. So you have just the NAPALM layer doing this translation between native configuration and well-known models that are supposed to be vendor agnostic. The cool thing about this is that you get not only an abstraction of how to operate the network, but you also get an abstraction on how the data is supposed to work across different vendors. So you can actually get the configuration from let's say, from Cisco and translate it into native configuration of something that Juniper or Arista may understand. That's actually quite powerful, as you can start just replacing devices without that much complexity.
Yeah, I imagine that would be interesting use case to be able to have one network switch or piece of network hardware that you want to then replicate in either a new data center or just redundancy within your existing network, and be able to say, just pull the configuration from one and load it onto the other, irrespective of what the actual underlying hardware and software systems are on it.
Yeah, that's super interesting. And the cool thing is that because now you're mapping this native configuration, which is just text in most of the cases, into an object, you can start doing other cool things. Like you can, for example, simulate changes. Like, okay, let's imagine that I have this configuration, which might not be living anywhere, right? Like maybe just something that you just handcrafted because you wanted to test something. So yeah, let's imagine that I have this blob of configuration. What would happen if I apply this other blob of configuration on top of it? Or you can start doing actual simulations based on backups of your configuration. You don't even have to have like a live device to do the actual diff of the configuration. You can just grab like a configuration backup file or whatever and start just simulating changes.
And one thing that I'm curious about is if there's anything that you're losing by using NAPALM as an abstraction layer on top of the underlying hardware, because as the different vendors, I'm sure they're trying to expose certain features that are unique to them to be able to differentiate themselves in order to be able to drive people to want to buy their hardware versus somebody else's. So is there a trade-off when you're using NAPALM versus trying to take advantage of whatever sort of special capabilities that underlying piece of network equipment has?
So NAPALM mostly deals with configuration management plane, which means that you don't really lose any feature. Well, you might lose like tiny features like, oh, you can add a comment in this particular before, I don't know, like in this block of configuration, you can actually add a comment, and you cannot do that on another platform. Like you may lose small features like that, but the actual value of the device, it's going to be on the data plane. Like, oh, I support this this protocol and this other platform doesn't. And because NAPALM deals with the configuration management plane, you're not going to be losing those features, right? Because it's a complete different plane. Like you're still going to be able to configure with NAPALM that feature on the device.
And going back briefly to the configuration management question, are there any trade-offs involved when you're using NAPALM embedded in one of those tools versus just using it directly, either via a script or using its command line capabilities?
So all the features that NAPALM support are actually implemented on the modules, at least for Ansible. I think that it's the same for Salt, right, Mircea?
Yeah.
Yeah, so all the features are actually implemented. So it's just a matter of what you're trying to do. You just need like a simple script to retrieve your LLDP neighbors, for example. I mean, you may as well just like write it yourself, because it's going to be like, I don't know, like 10 lines of Python. But if you want to do something more complex, like, I don't know, like a event-driven automation, I mean, just use Stackstorm. I mean, don't try to reinvent the wheel, or Salt, or whatever. Like, it just depends on your use case.
I would say you actually have many more benefits if you use a tool like that on top of NAPALM, because you ultimately write some templates to generate your configurations, right? And in a tool like Ansible, for example, you can use the embedded filters, that some filters that are already available for Jinja, for example, or I don't know, in Salt you can take abstractization to a whole new level, because you can use many other variables in the template. You can reuse thousands of functions inside the template and so on. So I would say you have many benefits doing this, but you don't lose anything.
Yeah, nowadays most people is using NAPALM actually via some framework like Ansible, Salt, or Stackstorm. I mean, I don't think that there are that many users just using NAPALM directly. can be done, but I mean, you get a lot of goodies if you just use a framework.
Yeah, I use Salt pretty regularly in my day-to-day basis, and so that's sort of where my preference lies. And so that was a bit of a leading question, but and then quickly with Salt Stack, I'm assuming that the majority of the interaction that you're doing with the network devices is via the proxy minion capabilities, or is it also operating directly against the network switches via the APIs?
Yes, at the moment only through the Salt proxy feature, but we are thinking for the next release in Oxygen to have also a roster that do not keep the proxy process always running. So there are some environments where you need to push a configuration change, I don't know, once per week or per month, and it's a bit pointless to have a proxy process always running. And while the roster is on top of the Salt SSH subsystem, which is basically the equivalent of Ansible, and you can leverage this automation like that. But even so, I would say that there are very good ways to start the proxy process only when necessary. You only need to have in a Salt language a Salt state that starts the process, enables it, applies the configuration changes, and stops it. So it's about 4 more lines of SLS.
And when I was going through the documentation, I was noticing that it's possible to merge the configuration that exists on the device with the desired configuration that you're applying. And having worked with Git a fair amount, I'm pretty familiar with the dreaded merge conflicts. So I'm wondering how you manage those and how you prioritize the application of the nested data structures that are going to be exposed in terms of do you just completely override them in one direction to the other, or do you merge them together, or is there some sort of tunability parameter for how that's managed?
So when you're merging configuration with NAPALM, you are actually merging a state into another. Like there are no intermediate states. So here there is no branching or anything. So there cannot be conflicts as you may have with Git when you start like merging different branches and you have conflicting changes because you're always going from A to B. If you want to merge different branches, what you would be doing is actually manage your configuration files with Git directly. So you would be solving all the problems there. And then NAPALM is just the delivery mechanism of the resulting configuration into the device.
Yeah, I would add one more sentence here. This assumption is based on the fact that you are able to replace parts of configuration, but there are some devices in this world that are actually not able to replace chunks of configuration. In that case, there are also good ways to do so. For example, you can retrieve what is configured now, then determine in your tool what needs to be added and what needs to be removed.
Yeah, with the NAPALM Yang framework that I mentioned before that integrates these open config models, we can actually go one step further because as Mircea was mentioning, like we rely nowadays on the devices themselves doing that merge operation, but because we are operating with actual objects when we have when we're using the NAPALM Yang framework, we can actually compute the delta ourselves, and we can actually figure out the exact commands that you have to run to go from state A to state B. So with that, we'll actually get that merge support consistently across all the platforms. But as I mentioned before, there is always going to be going from one state to another without branching or anything. You want to do this branching, you will have to solve it before using Git or something like that, because we didn't think it was actually worth it, like implement something as complex as this when there are tools already being able to do that.
And when you're working with NAPALM, it seems like a fair bit of what you're doing is somewhat declarative as far as applying the desired state of the device as opposed to doing it in a procedural manner. So I'm wondering, what are some of the difficulties? How does that differ from managing a general purpose operating system in a declarative model similar to what configuration management exposes?
Well, I mean, I wish that was actually true because unfortunately it's not entirely true. Like when you're managing most platforms, what you actually have is a command line that you use to instruct the device to go to a desired state. For example, let's imagine that you are configuring like the network stack of a Linux machine. What you would be doing is you would just be editing a bunch of files, and then you would be restarting the network service, right? But imagine that what you have instead is you don't have this network service. What you have instead is just the IP route tooling. You only have the IP command to actually like, oh yeah, I want to check which IP address I have. I have this one, so now I have to remove this one. I have to add this other one. My routing table looks like this, so I have to remove this route. I have to change this other one. So unfortunately, most platforms behave like that. Like you don't really have this declarative model. What you have is a CLI to instruct the device how to get there. So that's actually the main challenge with automation on the networking world. Fortunately, some vendors are starting now to provide this declarative model where you can actually send the desired state, like this is the config I want, just apply it. So in those cases, the thing is getting way, way better. But you still have the problem that those platforms, most of them, they still behave as a single service. So you cannot just reconfigure the NTP service, for example, or just the BGP neighbor. You have to actually say, this is my whole configuration, reload all the services. And a lot of people cannot actually do that because they don't have an inventory with all their parameters somewhere, so they cannot actually rebuild this full configuration and just reapply it. So I would say that that's the actual challenge.
If I can mention, someone asked me at some point, I want to have this configuration on the device, and I want to run, let's say, the state or some tool that updates the configuration, but I don't want to put this data in the source of truth. How can I do it? Well, that's an unsolvable challenge. Put it in the source of truth.
Yeah, so in the past, when I've been going from a non-automated environment to an automated environment, I would end up doing a lot of parsing of the configuration. Like you connect to the device, you parse the configuration, you try to extract the data that you're not automating yet, so you can actually reapply it, and then automate the bits that you are already automating. And you just keep moving from non-automated blocks to automated blocks just gradually until you manage to automate everything. But it's certainly a big task because, yeah, you cannot really automate the network service by service. You have to automate either everything or just do a lot of complexity and state management yourself.
And we've covered a bit of the technical difficulties of managing these different classes of device. So I'm wondering if there's any other challenging aspects of working with network hardware in a programmatic fashion.
Yeah, I would say it's mostly inconsistencies and buggy code, but I would leave this one to Mircea. I mean, he loves this one.
Yeah, a lot. Yeah, there are many challenges, but I find it fun at some point, but afterwards it gets ridiculous. Inconsistency in terms also in the way it presents you the operational data, but also at the configuration level. Beyond this, because somehow this is natural. I mean, each vendor comes with its own methodologies, its own syntax, otherwise someone will go and will apply the law and will tell you you have to pay some money because you use my syntax, right? And beyond this, the APIs most of the time are buggy, and sometimes simply don't work, or they are not consistent even on themselves. For example, Cisco has many platforms, and each one having its own obscure versioning system. For example, iOS XR has an API called the XML API. On iOS XE, you have something else. On iOS, you don't have anything. So all of this being manufactured by Cisco. So this is only about Cisco. Think about also from a network vendor to another. These APIs simply don't work sometimes. I have an issue right now when I simply cannot start the process for the API at all. This is ongoing for 1 month. I have rebooted the system, but still doesn't help. And this is kind of challenges we are facing, and at some point we may decide that screen scraping, although it sounds and it is very bad, and it's a very poor way to automate, it turns out that it may be more reliable than waiting for a vendor to tell you what to do with an API which you can't even start.
That was so not only even between different platforms, like some platforms within minor versions may have like different data structures, or even the same platform might return different data structure for the same API call, depending on certain cases. Like for example, like you have your BGP neighbors and you want to retrieve them. So if you have only one BGP neighbor, you will get just like a dictionary. While if you have a list of, but you have multiple BGP neighbors, you will actually get a list of BGP neighbors. So you need in your code to start accounting on those things. Like, okay, am I dealing with a list or with a dictionary? Because otherwise you would just going to break your code.
It's even on the same platform, same version, same box. If you configure, for example, let's say an NTP peer will give you back a dictionary, like or let's say in a JSON format, but the equivalent in Python a dictionary. But if you have 2 or more NTP peers, it will be a list.
And so, given the fact that these APIs are so poorly maintained and poorly implemented, it seems that they're sort of a second-class consideration from the networking vendors. So, if the APIs aren't accessible or consistent, then what is their intended mechanism for you to be able to interface with and operate on the devices?
I want to start clarifying that this is not the case on all the platforms. Like there are some vendors. Juniper being the notorious one here, that are really, really good with APIs, like it's a first-class citizen. But the thing is that for most vendors, they didn't care before about automation because their customers weren't asking for it. So SSH is everything they have, to be honest. So I don't know. I hope that things are starting to change now because actual operators are starting to demand automation. But right now, I mean, they will tell you like, yeah, this is what it is, just SSH. And then you just have to fall back to screen scraping again.
And given the fact that NAPALM is integrated into a few different pieces of tooling and frameworks and seems to be fairly popular, I'm sure that there are some interesting or unusual instances of NAPALM being used in the wild that you've heard about. So I'm wondering if you can both share a bit of what you've seen that you thought was particularly noteworthy.
Do you want to start, Mircea?
Yeah, I will take some examples starting with us at Cloudflare. We are using NAPALM, for example, to monitor the backbone of the internet, as we have a need to see how reliable our IP transit providers and how much we can trust them to forward our packets. To bring more context, we don't have our own fiber source means of transportation. We just pay some guys to put a fiber in our devices, and from there on they carry these packets. But very often they have packet loss, which means somewhere more than 20% of packet loss. And in that case, we need to reroute the traffic to send our data through to different guys. And we're using NAPALM in the very first place to retrieve the performances and to monitor how much packet loss they have. We would basically use SNMP, but there's a different problem there. Not only that each vendor has its own SNMP implementation, but others present the data in a very poor way. For example, on Cisco IXXR, if you specify a tag name for a probe more than 13 characters, when you try to retrieve it via SNMP, it won't give you anything. And there are many other stupid things. Moving on, monitoring this, and I said we rerouted the traffic. That triggers a lot of things. That means apply the configuration change on the device with NAPALM. And then after this configuration change is applied, is a couple of things. Also updating our internal tools, posting to our internal chats, updating a very nice map with points of presence where we rerouted traffic, updating our communication with customers, our status page where we say that the traffic is rerouted, sending emails and so on. We are also using NAPALM, although I'm not speaking about strictly the main NAPALM. I'm going to remind again about that new kid, NAPALM logs. We're starting using it and listen to the events in our network, what's going on, and we act immediately and reliably on these events without having any impact on our network or customers.
So I've seen also some people replacing their SNMP based monitoring system with NAPALM, with all the getters that we have. So instead of just checking the interfaces with the SNMP MIP, just like retrieve it with the NAPALM getters. We also have this validate functionality built in NAPALM that lets you define desired state. Like, for example, you could say, I want to make sure that I have this BGP neighbor configured that is up and that it's sending me a certain amount of routes. So you can just define that on a YAML file with a very simple DSL to define the rule. And then NAPALM just figures out how to retrieve that information and make sure that it's in there. And if it's not, if the rule is not actually passing, it will just give you a report and like, okay, yeah, there is a compliance issue, so you're failing on this. So I know that some people is working on replacing like their time series alerting systems with this functionality, which I guess you could call it more like test-driven monitoring. I don't know, because you're actually testing the network all the time, making sure that you have certain states in. And I have also built myself what I like to call like immutable infrastructure for the network, which means that I actually, every time that do a change on the network, regardless of how small the change is, like could be just like a change of an interface description, for example, what I do is actually rebuild the entire configuration, and I send it to the device, and I tell the device, like, this is what I want. I mean, if there is something else, just get rid of it. So with this, what you can actually ensure is that you always are on a known state. Like if an operator would connect to the device and do a manual change, because you're actually rebuilding the state from scratch, you would actually get rid of that unknown state that the operator introduced.
Yeah, because David was saying about configuration. Yeah, I can give one more detail, something very interesting. We have our device configuration is imperative, meaning that exactly what we have in the source of truth has to be reflected on the device. And the configuration has diverged over years. A lot, and there are still some parts of configuration that are not there yet, are not yet prepared to be run, to be applied configuration changes automatically live. And because of this, and we are using the NAPALM functionality to retrieve the diff, the configuration difference, we at specific intervals, it is run a tool that determines the diff between what we have in the source of truth and what you have actually on the device, and sends an email reminding you that okay, this is not correct. You need either to update your source of truth, either try to make your configuration on the device to be consistent.
And so we've been using a lot of different networking acronyms and talking about various aspects of doing network automation and managing different types of networks. So for somebody who's interested in learning more about the fundamentals of network management and network operations, what are some of the resources that you would recommend that they look to?
So, for example, network2code.com has lots of resources, has some labs, and there is actually a Slack community behind it, which is very active. Both Mircea and I are in there. We actually have an NAPALM channel where lots of people is all the time just asking questions and helping each other, and just like chatting is kind of fun. There is also ipspace.com he has a lot of webinars and information about automation as well. Pinet.twb-tech.com is also a great resource if you're familiar with NetMiko. He's the author of NetMiko. And there is also now a no really book called Network Programmability and Automation, which I haven't actually read myself, but I know the authors are really good, so I'm confident that the content will be of high quality.
And Mircea, do you have any resources to recommend?
I would recommend also the packetpushers.net. There's a lot of information there and podcasts and so on, specifically about networking and also network automation. I sometimes blog on my own website, mirciaulinic.net, about also about networking and also network automation and so on. I trying to put information as often as possible, although I don't really manage to.
Yeah, keeping blogs up to date is definitely more effort than it seems to when you first get started.
Yes, definitely.
So for anybody who wants to follow what you're both up to and keep up to date with the work you're doing and with the state of NAPALM, your contact information is in the show notes, so I'll refer people there. And with that, I'll move us to the picks. And so I've got 2 picks this week that are germane to the topic at hand. So one of them is an IETF RFC called The 12 Networking Truths. That is actually much lighter reading than any of the other RFCs that I've perused in the past. And it's quite entertaining. So I definitely recommend people take a look at that one. And then the other one is a post that is falsehoods programmers believe about networking, which is just a bunch of contradictory truths, all of which are factual and all of which are quite entertaining as you read them together. So I definitely recommend people take a quick look at that as well. And with that, I'll pass it to you. Do you have any picks for us today, David?
Yeah, I mean, I've been reading, or rather listening to The Fear Saga. It's a sci-fi series, and it's just great. I really recommend it if you're into sci-fi. Also, I discovered recently VR. I think it's just great. I think that it's not going to be AI. It's actually going to be VR what's going to bring humanity to an end.
And Mircea, do you have any picks for us this week?
For me, the week has just actually started. I've been quite busy yesterday, but I'm reading now a book that really calms me down and makes me feel good. It's called Daily Zen or the Zen book, and I get a lot of good advices there.
All right. That sounds like something I'll be needing to take a look at as well. So, with that, I would like to thank you both for taking the time out of your day to join me and tell me about NAPALM and the work that you guys are doing in your respective positions and how you're using NAPALM to manage the networks that keep the internet running. So, I appreciate your time and I hope you enjoy the rest of your days.
Yeah, thank you.
Thanks for the invite. Cheers.